Dimethylmercury is an extremely toxic organomercury compound with the formula CH3,2Hg. A volatile, flammable, dense and colorless liquid, dimethylmercury is one of the strongest known neurotoxins. Less than 0.1 milliliter is capable of inducing severe mercury poisoning resulting in death. The compound was one of the earliest organometallics reported, reflecting its considerable stability. The compound was first prepared by George Buckton in 1857 by a reaction of methylmercury iodide with potassium cyanide. Later, Edward Franklin discovered that it could be synthesized by treating sodium amalgam with methyl halides. It can also be obtained by alkylation of mercuric chloride with methyl lithium. The molecule adopts a linear structure with HGC bond lengths of 2.083. Dimethylmercury is stable in water and reacts with mineral acids at a significant rate only at elevated temperatures, whereas the corresponding organocadmium and organozinc compounds, and most metal alkyls in general, hydrolyze rapidly. The difference reflects the high electronegativity of Hg, Pauling N equals 200, and the low affinity of Hg2 for oxygen ligands. The compound undergoes a redistribution reaction with mercuric chloride to give methylmercury chloride. Whereas dimethylmercury is a volatile liquid, methylmercury chloride is a crystalline solid. Dimethylmercury has few practical applications because of the risks involved. It has been studied for reactions involving bonding methylmercury cations to target molecules, forming potent bactericides, but methylmercury's bioaccumulation and ultimate toxicity has led to it being largely abandoned in favor of the less toxic ethylmercury and diethylmercury compounds, which perform a similar function without the bioaccumulation hazard. In toxicology, it still finds limited use as a reference toxin. It is also used to calibrate NMR instruments for detection of mercury, 0 ppm for 199 Hg NMR, although diethylmercury and less toxic mercury salts are now preferred. Around 1960, Phil Pomerantz, a man working at the Bureau of Naval Weapons, suggested that dimethylmercury be used as a fuel mix with red fuming nitric acid. This was never done, although it did lead to testing a red fuming nitric acid unsymmetrical dimethylhydrazine rocket with elemental mercury being injected into the combustion chamber at the Naval Ordnance Test Station. Dimethylmercury is extremely toxic and dangerous to handle. Absorption of doses as low as 0.1 milliliters can result in severe mercury poisoning. The risks are enhanced because of the compound's high vapor pressure. Since it is highly lipophilic, it absorbs through the skin and into body fat very easily, and can permeate many materials, including many plastics and rubber compounds. Permeation tests showed that several types of disposable latex or polyvinyl chloride gloves, typically about 0.1 millimeter thick, commonly used in most laboratories and clinical settings, had high and maximal rates of permeation by dimethylmercury within 15 seconds. The American Occupational Safety and Health Administration, OSHA, advises handling dimethylmercury with highly resistant laminated gloves with an additional pair of abrasion-resistant gloves worn over the laminate pair, and also recommends using a face shield and working in a fume hood. Dimethylmercury is metabolized after several days to methylmercury. Methylmercury crosses the blood-brain barrier easily, probably owing to formation of a complex with cysteine. It easily absorbs into the body and has a tendency to bioaccumulate. The symptoms of poisoning may be delayed by months, resulting in cases in which a diagnosis is ultimately discovered, but only at a point in which it is too late or almost too late for an effective treatment regimen to be successful. Methylmercury poisoning is also known as Minamata disease.